Well, welcome to this lecture on electrical safety in healthcare. And I hope you find a little humor in the title here Healthcare Electrical Safety Inspections. Do we really have to check everything? Yes, well, sort of. It's been an interesting journey in healthcare. I started out, as some of you may know or remember, as a clinical engineer or a biomedical engineer. It's known by either name, although biomedical is often more accurate because clinical engineers tend to be involved much more in clinical processes and procedures. We tend to be more inside of the space with the nurses and the doctors and such working with them, whereas biomedical is more of equipment technicians. Not to be confused with biomedical, which has to do with, I guess, arms and legs and prosthesis and such. However, having been a biomedical engineer, um, electrical safety inspections was core to not just the job, but it's really essentially what created the biomedical engineering profession many years ago. The safety issues around electrical equipment, particularly in invasive procedures, back in the 60s, resulted in a number of electrocutions and deaths and injuries, as they found out, due to faulty grounding issues inside equipment. And so you'll find most any biomedical engineer today and who's been around for a while has a pretty clear understanding of, you know, safety testing, electrical safety inspections, ground and leakage and lead testing for devices that have electrodes, and pretty familiar with the recommendations, the requirements, and the ratings for resistance and for leakage, for electrical leakage. But that being said, it's ironic. There's always something to be learned. Having worked again in clinical engineering all these years and having done thousands upon thousands of inspections, um, in recent years, I discovered some nuances to safety inspections that actually I had never known. And again, it's kind of a minor nuance, but yet at the same time, nuance nonetheless, but a requirement when you look at NFPA 99. Where it got interesting for me in my career, and this is part of the reason for this lecture, was when I became a facilities director, and I saw that the maintenance personnel had um, devices that were, electrical safety analyzers. But it was very quickly apparent to me in my two facilities they either didn't know how to use them or they didn't use them. And if they did use them, it was in an extremely limited fashion. Because whereas biomed is driven by preventive maintenance, maintenance in facilities is driven by repair. And I think you can almost flip it. I think biomed probably spent 60% of the time, 70% of the time doing preventive maintenance and 30% of the time doing repairs. And just the opposite when it came to maintenance. They spent probably 60, 70% doing repairs. And actually, I would say probably 10% of the time, maybe 15 or 20% of the time doing preventive maintenance, and the rest of the time for both departments, if you will. There was some time in there for projects. But it was a challenge to get maintenance folks to buy into the need for electrical safety inspections, and primarily because the surveyors and the accreditors never really asked for electrical safety inspections when it came to maintenance folks. In fact, today they still really don't ask for electrical safety inspections when they look at maintenance. They're often looking at different things. For example, they're focused much more on, generator testing and life safety inspections for walls and for fire panels, and they're more the physical environment and more the big major equipment, and they're looking more for functionality and such. And I think because of that, the facilities and maintenance world has sort of slid, if you will, when it comes to inspections. The other thing that's been a challenge when it comes to maintenance, when it comes to electrical safety inspections, is that often maintenance doesn't necessarily see the equipment they work on as being patient care or clinical. Whereas, of course, in biomed, nearly everything they touch is patient care and clinical. And that creates some challenges, especially when I've seen obvious contradictions where if the beds are covered in the OR, let's say you have operating room beds or even patient room beds that are covered by Biomed, you can bet your bottom dollar there's going to be an electrical safety inspection done on all those pieces of equipment. Same thing with like blanket warmers or maybe even certain kind of operating room lights and such. However, all of a sudden, because it becomes a maintenance responsibility, you don't see the electrical safety inspections happening as consistently. And this is again another one of those issues I think within the maintenance world. And I know that the answer predominantly has been over the years we're just too busy, and it's kind of a waste of time or we don't have time to do it. But that being said as well, enters a third conflict when it comes to electrical safety inspections, and that is personal care devices and the revolution and the evolution of low voltage technologies such as iPads and cell phones and all kinds of music devices and computers and personal laptops and such coming into the healthcare arena and healthcare environment. Having said this, technically every single device that walks into healthcare we become responsible for. So from a technical perspective, yes, we are meant to check everything, and that can be very burdensome, especially with again personal patient devices. And then, especially when equipment comes in, again when it's entry controlled or when it comes into the building, there is a mandate that things are checked when they come into our possession. Not necessarily personal care patient devices, but more specifically, definitely when it comes to equipment that we purchase for the hospital. So when it comes to initial inspection, everything that's electrical is meant to have an electrical safety inspection. Minimally a physical inspection. And now when I say physical inspection, one of the challenges again, because the revolution of design and technologies, is something called double insulation. We have equipment out there now, lots of it, that it has no metal, if you will, external part of the device that you can touch. It is completely enshrouded in a non-conductive case, typically plastic, and it's double insulated. In other words, there's an extra wall in there built where you cannot get to a metal part. So even if there's an internal short in the device, it's not going to pass a current externally. And then, of course, you get into the difference between three-prong plugs and two-prong plugs, things with grounds and things without grounds. And these conversations go on and on. What needs to have a third ground, and what can have two prongs in a patient care environment. I think to the rescue for most of us after the initial inspection is the risk assessment, and also clearly understanding the definition of patient care environment, if you will, the clinical environment, and then the non-clinical environment. And those really are the tools we have to really just nail. We have to understand when we have a piece of equipment in an office that essentially is a business function, like an electrical stapler or maybe like a paper shredder or things like that. We don't have to test those things because we may have done the initial inspection, but beyond that, like anything else, it's in a non-clinical area. The patients or the users, the users, which are the employees typically, they can evaluate a device for it, not needing to be tested, or when it's failed, or when there's a frayed cord or something like that. And we can create a policy and a risk assessment around that. However, when we get into the clinical environment, not the patient environment, but the clinical environment, where we have staff and we have, let's say, like laboratory or radiology, or maybe it's a nurse's station or something like that, that shifts things a little bit for us. And we have to, again, do a risk assessment and make determinations what can and cannot be excluded from our ongoing scheduled inspections. And by and large, technically, we're meant to inspect nearly everything in that environment, with few exceptions, particularly a physical inspection. I know that when we have done discussion boards, people have talked about, like the kitchen, for example. There's lots of little appliances in kitchens that never get inspected. It could be a mixer, a blender, or a microwave, something like that, but it gets moved around and plugged in and unplugged and plugged in and unplugged all the time. And something like that can become a hazard, both a fire hazard as well as electrocution hazard, over time, and they really should be inspected. Now, again, I would say that probably you could come up with some way of maybe having the department do some inspection, although that's not their core responsibility. There's too many users, and by and large, they're just not going to do it. And kind of along the same lines, you have environmental services. Environmental services is one of those departments that uses electricity all over the hospital. And they don't just use electricity, they will unplug and plug things in multiple times a day on one shift. And they really do damage a lot of our outlets, and they damage a lot of their plugs, by the way that they do or don't pull those plugs. I mean, there's no doubt, that having plugs located within just a foot and a half or so from the floor adds to, the issue, as folks won't bend over and pull on the thick insulation part of the cords. And really, that's one of the emphasis I want to make with this particular lecture with you is that, we need to do risk assessments, and people like environmental services, we probably ought to do extra training with those folks because they do cause a lot of maintenance issues and potentially safety issues. And we all know that not all people coming into those departments are necessarily really thinking about the implications of pulling on a cord, that's 20 or 30 feet away to get to unplug so they can hurry up and go to the next job and do the next vacuuming or the next scrubbing or whatever they're going to do. So really I'm sure that when you work in healthcare and you work with like an environmental services department, you're going to find that again, like vacuum cleaners and things like that, they don't always get inspected on a regular basis. This is an area where we have a lot of room to improve. We need to have better inventories. We need to have better risk assessments, and we need to have better checks. So really, at some point, someone's going to start paying much closer attention to this, particularly in the facility side. Again, I would say, gander to say most maintenance, clinical engineering side, biomedical sides have this down pretty good. But I think in the maintenance world, there's a huge opportunity to improve this. Now, going back to that nuance of something that I had learned recently even, it is required. Interesting enough, as you guys read through the chapters, you talk about how to do safety inspections. It's going to talk about ensuring a proper ground. So what you do is, you connect the probe that's on the safety analyzer to some chassis or metal external part of the device, and then you plug it in. And what you do is you read, how much leakage there is, or how much leakage, I'm sorry, you read the resistance of the ground cord through the device back to the outlet. And you want to make sure, obviously, that you have a very good solid ground. In other words, that the internal ground is connected to the cord ground, which is the safety, for everybody. Now, having said that, one of the requirements, and you'll find it in your reading, is that you have to flex the strain reliefs on both sides, and that's pretty much meant to be recorded. I would challenge you, for those of you who work in healthcare right now, or those of you who are going to come into healthcare, to take a look at your inspection sheets and see if there is a specific line item that says that the strain relief was stressed. And for those of you who may not be familiar with the term strain relief, where the cord goes into the device and where the cord goes into the plug itself, at that point, both sides, there's usually some mechanism that pinches the cord so it doesn't pull internally. And where that pinches is also a strain point for the cord as it gets plugged and unplugged, or as it gets placed on a counter or wherever. It's going to be turned, and it's going to be bent in almost a 90 degree in many cases. And that flexing and bending over time can certainly cause stress on the internal wires and can end up in a break, particularly of the ground, which is the safety. And I can tell you right now that I don't recall on any of my checklists that I ever had where I had a check or a box where it was strain leaf stressed at chassis and strain leaf stressed at the cord. So that's one of those little nuances. Again, it'd be interesting to hear from you as you go through this week, if you check lists that you have for safety inspections, for electrical inspections, to let me know, is that on your list? and to validate inside the NFPA 99 that requirement. So most of the other stuff is pretty standard, and there's often also questions about reversing polarity on equipment. And if you look at the standards, some equipment does require reverse polarities when checking leakage, but other devices don't. In fact, many general use devices do not require a reversing of polarity. It's primarily on equipment that is patient care. So that's a quick inspection. Again, in the future, I plan to have a lot more examples through this lecture for you folks. This was a complete verbal. I hope you captured the essence of this conversation, which is really we have a lot of low-hanging fruit and we can improve in this area. Again, the goal is to be different day one, and this is just one of those little nuances that can help us do it. So really, again, the key points on this lecture is: one, is we have a lot of low-hanging fruit. Two, that the uh, that the requirement to do everything can be mitigated through risk assessments. Again, that's a common thread throughout the lectures. And three, pay attention to the detail of the standards. There's more detail there sometimes, and nuances that there's going to be gotchas later, particularly the strain relief issue that I talked about a moment ago. I hope this was informative. I hope that helped you kind of get a little more clarification or a little more awareness of this section of the book and your future. That ends this lecture.